on video 70.
Man, we're making it far along. It's second semester. We're cruising along. All right. When was our guess for hitting 100? I think March. Yeah, March-ish.
Well, that would make sense.
30,
We got 30
about
days.
6 more weeks of school. Maybe early April. Spring break time. Something like that. That'll be nice. Anyway, video number 70. Variance and standard deviation. So variance is a measure of spread we didn't talk about earlier, but we need it for random variables. We're going to learn how to calculate these from a probability model.
Right. Sorry.
All right. What do we have here, Mr. Lewis?
We have our 3 spinners that we dealt with in class yesterday or today. It depends when you're watching this video.
There yesterday.
Okay.
Or today.
Right. So we had, now these 3 spinners we were able to calculate the expected value of.
We did?
But.
We did.
Yes.
I'm sorry.
In class. Did you not remember last period or something? So what we want to look at is see all these numbers. This one has a bigger spread. This one has a way bigger spread. And this one, they're all the same, right? So we want to be able to calculate the variance and the spread of what we'd expect.
Yeah, so imagine spinning each spinner many times. They all had an expected value of 7. You'd expect to win $7 in the long run. But if you record the results, the average would be about 7, but the standard deviations would be different. The spread about the average would be very different for these games.
Right.
The one in the middle has actually no variation around 7. It's the same value always. The first one has some risk to it. It'll vary about 7 a little bit. And the numbers for the last one will vary greatly around 7.
Yeah.
So now we want to start talking about, after having expected value, a measure of spread. How spread out do we predict the values will be around that average?
Right.
Okay. So we're going to learn how to use the formula to do that.
Okay.
All right. So here's the first spinner. I'm going to take it one spinner at a time.
Yes.
And we saw a formula for expected value. Maybe you could write it up here. E of x, just to remind you, equals the sum of x times p of x. So that was our first formula. That's the formula for expected value. You multiply the value of the random variable times its probability and add it up over all the values. So that's one formula we have under our belts. The next one's a little bit more complicated, just like standard deviation is more complicated. It's for the variance.
Right.
And we're going to calculate that. After you have the variance, it's like one step away from standard deviation. If you take the square root of it, you have the standard deviation.
Yeah.
So the variance is the real work.
Right.
Okay. All right. So it's almost the standard deviation, just one step away.
Right.
So here we're going to compute it. What you do is you take each data value and subtract the average, square it, and then multiply by the probability. So this would be 20 minus 7, because the average was 7.
Thank you.
Squared times the probability of 20, which is 1/4. And we do this for each of the terms.
Right.
This should bring back some memories. We used to find how far a number was from the mean, and then square it, and then did some other things to find standard deviation. So this is kind of like what we did earlier on in the year with standard deviation for data.
Right.
Okay. So I better get busy.
Right.
So this is kind of intense calculator-wise. We'll do this for just a short while, and once we get the hang of it, we'll start using our calculator totally for this. So 20 minus 7 squared times 0.25 plus. So this is a very mechanical process.
Yes, it is.
All right.
Ripe with error possibilities.
True. Plus, so you just got to take your time, make sure all the parentheses are entered. 9 minus 7. I'm still working at square.
It actually might be easier to go through and
times 0.5.
Subtract them first. Like this.
That's 13 squared.
13, thank you. Of course, if you don't subtract them correctly, this doesn't, matter. Times 1/4.
Good.
Plus 2 squared times 1/2.
When you do all that,
and what do we get?
116.5.
16.5.
Okay, so hopefully you typed everything okay. So I'm checking it out. Looks pretty good. Like I said, there's a lot of room for mistakes, but I think we got it. All right, now that's the variance. And we didn't care about variance before, but it's important with random variables, and we'll see why in a few more days. Now, take the square root of it, and we have the standard deviation. So the square root of that is 116. Square root of 116.5 is about 10.8.
10.8.
So this is a theoretical value. If we did this many times and we entered it into a calculator and find the standard deviation, this should be approximately 10.8.
Right.
Okay. All right. So in the long run, we expect the average to be 7, and 10.8 would be the standard deviation of our winnings. Okay, let's go to the next one. This one's going to be a piece of cake.
Yep.
All right, I got the easy job on this one. So again, up at top, the expected value was 7. Okay, now, you can never get anything other than 7.
Right.
So if we did this 1,000 times, we'd have 1,000 sevens.
Yes, we would.
The mean would be 7, and the standard deviation would be
0.
So we should get 0 for the variance and standard deviation.
We should, if we get this right.
All right.
All right. So the sum, so we got 7 minus 7 squared over times 1/4 plus 7 minus 7 squared times 1/4 plus, it's like a broken record,
I like
7
this
minus 7 squared, 1/2.
Yep.
And guess what 7 minus 7 is?
So it's 0.
It's 0, so we get 0 plus 0 plus 0, and that, of course, is equal to.
And then when you
0.
take the square root of that?
Yeah, the square root of 0, surprisingly, is also 0.
Good. So it's a very consistent game.
Yes.
Very little variation around 7.
Right.
All right, next one has a lot of variation.
Yeah,
So if we did this many times, and the mean would still be 7, but the spread, the standard deviation about 7 is going to be kind of big.
Right. So here we have.
All right, I'm going to start this already.
28 minus 7 squared times 1/4 plus negative 1,000 minus 7 squared times 1/4. Oops, 1/4 plus 500 minus 7 squared times 1/2. And what is our variance, Mr. Miller?
375,042. And then when we take the square root of
That
that,
is a big old number.
we get 612.4. So that's a large standard deviation. So
Yeah,
as
I
we
would say
said,
so.
this one, if we do it many times, the results are going to have a large spread around 7.
Mm-hmm.
Okay. All right. What's next?
It's them.
Alrighty. Okay. So here we calculated the expected value for this yesterday's video.
Yes, we did.
And it's $2. You expect to win $2 from this game. Okay. So maybe, Mr. Lewis, we can label the probabilities. Who'll be that guy? A 1 is a 1/2. Just in case it's hard to see. 2, 1/4. 1/8 chance of winning 3. And 1/8 chance of winning 5. All right, so we want you to calculate the variance using the formula you've seen on the previous page. Remember, 2 is mu. Maybe we could label that also. There's a few things going on here, so yeah, that was the expected value, or mu, in the formula. Okay, so use the formula to calculate the variance. Take the square root to find the standard deviation.
Mm-hmm.
All right,
Sounds good.
that's it.